Hello and welcome back everyone to another Alpha Math video. In this lesson, we'll be focusing on the geometric pattern. Consider the example 5, 15 and 45. Notice that to get from one term to the next term, you are multiplying by a constant ratio, which in this case is 3. 5 times 3 is 15, 15 times 3 is 45. And if you would like to work out the next term, just continue with the pattern by multiplying with 3. And that's basically how this pattern works. Now the way how we can find out our ratio, the constant ratio, is to always divide the terms, any two consecutive terms. So you can take term 2 and divide it by term 1, and that should be equal to term 3 divided by term 2. This is how you could test if your ratio is consistent. But like I said, any two consecutive terms, find their ratio and it should be the same. Okay, now let's have a look at our first example. So here we have the pattern 3, 6, 12 and 24. In order to write down the next two terms, you need to multiply by that ratio. So let's first calculate what our ratio is. Right, so we're going to take term 2 and divide it by term 1. Right, so that is 6 divided by 3, which is equal to 2. You can just test if it holds true if you take another pair of consecutive terms. So term 3 is 12, term 2 is 6, and 12 divided by 6 is also 2. Okay, now to find the next two terms, what we're going to do is multiply this 24 by the ratio 2. So 24 times 2 is equal to 48, and 48 times 2 is equal to 96. So here we have our next two terms. Okay, moving on to question B. Here we are asked to find a general formula to this geometric pattern. Now, the general formula for a geometric pattern is this formula I'm about to show you. A multiplied by R to the power of n minus 1, where A represents the first term and R represents the ratio of the pattern. N would simply represent the position of the term, and Tn would represent the value of that term. Now let's go ahead and substitute into our formula. So A, which is our first term, that is equal to 3. So we'll say 3 multiplied by our ratio, which in this case is 2. And then we say to the power of n minus 1. So that's your formula, 3 times 2 to the power of n minus 1. It's very important to note here that you cannot multiply A with R because at the moment they have different exponents. The exponent for 3 is 1 and the exponent for 2 is n minus 1. And when you have different exponents, you can't multiply the base numbers. So we'll just leave our answer like that. So this is our general formula. Okay, moving on now to question C. This one says, find the 8th term in this pattern. Okay, so we want to start with our general formula because this formula allows us to calculate any term in this pattern. And since we are looking for the 8th term, they're giving us the position of the term, it's the 8th term. So we can just substitute that with our n, and then we're going to calculate the 8th term. So 3 times 2 to the power of 8 minus 1. Now let's try and simplify this further. Okay, 8 minus 1 is equal to 7, and 2 to the power of 7 is 128. Okay, when you multiply that by 3, you get 384. Okay, so this is the value of the 8th term. And it's as simple as that. You start with your general formula, you substitute 8 with the position, and that's how you can calculate the 8th term. Okay, moving on to question D. Here they ask us, how many terms are there in the sequence? This term over here, 6,144, is the value of our last term. Now remember, if they give you the value of a certain term, you can work out its position. And if you know the position of the last term, then you know exactly how many terms there are in the sequence. Okay, so we're going to start with our general formula once again. 3 times 2 to the power of n minus 1. Right, let's substitute our value, 6,144. And the first thing we need to do in order to solve this exponent n is to divide both sides by 3 to cancel out this 3 that's hanging out in front. Okay, so that leaves us with the 2 to the power of n minus 1, and the 6,144 divided by 3 is equal to 2,048. Okay, now we need to get our bases the same. So 2,048 can be written as 2 to the power of 11. And then, since our bases are now the same, here we have the base of 2, there we have the base of 2, we can drop our bases and make the exponents directly equal to one another. Okay, so if n minus 1 is equal to 11, add 1 to both sides, and that gives you n equal to 12. So therefore, this means that there are 12 terms in this entire sequence. Okay, I hope you enjoyed that example. Right, moving on to question E. Here we are asked to find the sum of all the terms in the sequence. Now, when you're asked to find the sum of a certain number of terms, you want to go ahead and make use of your sum formulas. This is now a geometric pattern, so there's a different formula, different to the arithmetic sum formula. And the geometric sum formula looks like this. A times r to the power of n minus 1 divided by r minus 1. Right, so a in this formula is our first term, which in this case is 3. R is the ratio that we've been using all the time, so our ratio is 2. And n is the number of terms that we are going to be adding together. So the number of terms in the sequence, which is 12. That's what we calculated. There are 12 terms in the sequence. So let's now substitute these values into the formula. 3 times 2 to the power of 12 minus 1 all over 2 minus 1. Now we can simplify this bit by bit. Let's start with 2 to the power of 12. Okay, 2 to the power of 12 is equal to 4,096. We're going to subtract 1, then multiply that by 3. Also, 2 minus 1 is equal to 1. So if your denominator is 1, that doesn't change anything really. So let's first just subtract 1 by that 4,000. So it gives us 4,095. Now multiply this by 3 and you'll get 12,285. Okay, that is your final answer. This is the sum of all the terms in this sequence. From the first term 3 all the way to the last term 6,144. If you add up all those terms, they should give you this result. Okay. Moving on to our next, or last example, actually. Question F, it says, if the sum of the first n terms is equal to 1,533, find the value of n. Okay, so they are giving you a sum, and they're saying that it's equal to 1,533. You need to find n. You need to solve n for this equation. Right, so let's substitute our sum, 1,533. Then we substitute a's value with 3. R is 2. We don't know what n is, so leave that just like that. Okay, simplify the parts of the equation that you can simplify. Like, for example, the denominator. Here we have 2 minus 1, and that's just equal to 1. Okay, if you're dividing something by 1, it doesn't really change the expression at all. So we'll just leave it 3 times 2 to the power of n minus 1. Okay, nothing happens there. Now, instead of distributing the 3, which I guess I could do that if I'd like to, instead I want to divide by 3 to get rid of the 3 entirely. So divide both sides by 3. This should give me 511. And on this side, we'll have the bracket, which is 2 to the power of n minus 1. Right, now add 1 to both sides. So this is 512 equal to 2 to the power of n. Then express the 512 in its exponential form. So that would be 2 to the power of 8. And drop your bases. So therefore, n is equal to 8. And that's your answer. 8 terms. Okay, that was our last question for today. I hope you enjoyed this lesson. Subscribe and I'll see you in the next video.